Okay, hello everyone, welcome to my channel. So today we are gonna talk about a topic called RAG. RAG basically stands for Retrieval Augmented Generation. आजकल काफी trending topic है since the time is of LLM and vector DB. So इस वीडियो में we are going to implement RAG using Faiss DB and Python. So let's get started. तो यार implement से पहले we'll talk about कि RAG होता क्या है. So RAG is nothing, it's just architecture और एक model basically जो retrieval और generation को combine करता है. So what it does कि ये एक पहले retrieval information retrieve करता है from some database और फिर उस information को use करता है उस information के basis पे जो text को generate कर रहा है. So as we know, LLM is a generative model. So we are doing nothing, just adding some more knowledge to the LLM, since some knowledge might not be present in the training data of the LLMs. So हम बस जिसमें अपनी knowledge को augment कर रहे हैं to the LLM, so that when we are generating the text, it generates the text based on that information. So as you can see in the architecture, there is this documents. So हम क्या करते हैं कि जो हमारे documents हैं, for that documents we create some embedding using the embedding model. We store it in a vector store, which can be any different kind of vector database. So for this one, we are going to use Faiss. And when a user will send a query, तो जो LLM है वो क्या करेगा, इस context query में वेक्टर स्टोर से रिट्रीवल करेगा इंफॉर्मेशन की, एंड बेस्ड ऑन दैट डेटा जो कि वेक्टर स्टोर से उसने रिट्रीव किया है उसके अकॉर्डिंग एक कंटेक्स्ट सेट करेगा, एंड बेस्ड ऑन दैट इट विल गिव अस एन आउटपुट. ओके, आई होप द आर्किटेक्चर इज क्लियर. नाउ लेट्स जंप टू द इम्प्लीमेंटेशन. ओके, तो शुरू करने से पहले लेट अस सी सम डेटा. तो मेरे पास ये एक पीडीएफ है जो कि मैं यूज कर रहा हूँ, विच इज द कैंसलेशन रूल्स फॉर आईआरसीटीसी. सो एक 4 पेज का पीडीएफ है. आई एम जस्ट यूजिंग सम स्मॉल डेटा बिकॉज फॉर द ट्यूटोरियल पर्पस. एक 4 पेज का पीडीएफ मैंने दिया है. इसमें जो रूल्स एंड रेगुलेशंस आईआरसीटीसी से प्रोवाइडेड है फॉर द कैंसलेशन चार्जेस एंड ऑल दैट स्टफ, वो इसमें 4 पेजेस में प्रेजेंट है. ओके, सो वी आर गोइंग टू यूज दिस डेटा फॉर आवर augmentation. So let's start. सबसे पहले I'll just create a folder vector store. So what we are going to do is we are going to um, use the Faiss DB in order to create the embeddings. Okay. So first of all, I have this file loaddata.py. So let's set up the environment. तो मैंने यहाँ पर पाइथन का एक एनवायरनमेंट सेटअप किया है फॉर पाइथन 3.11 कोंडा से. आई हैव क्रिएटेड इट. And now let's install the dependencies. First of all, what we are going to install is we are going to install the LangChain, because we're going to use a LangChain framework here. Oops, sorry, I have not activated the environment. Just give me a second. Conda activate Python. There. Okay, install. Yeah. Now I'm going to install LangChain. So the package that we need here is, one is LangChain, another one would be Faiss CPU. I think we are going to use LangChain OpenAI. Any other package if needed, we'll see later on. Okay, so abhi let's install these packages and iske baad we'll meet. So starting up with the loading the data part. So the very first thing that we have to do is load the data. So जो मैंने डेटा अभी दिखाया है आपको, हम क्या करेंगे, we are going to create the embeddings for that and we are going to store it in the Faiss database. Okay. So as you can see on the screen, I have written some code in the loaddata.py. So the very first thing here I have imported is the PyPDF loader from the LangChain community. So you also have to install the LangChain community. तो यहाँ से I am importing the PyPDF loader because we have a PDF file. Second thing that we are going to import is the recursive character text splitter. So this is for the splitting the text. Uh, Third is from the vector store of LangChain community, I am importing the Faiss. And since I'm using the Azure OpenAI keys, so I'm going to import the from LangChain OpenAI. I'm going to import the OpenAI embeddings. Okay. Uh, Moving on to the code part. So, so this from secret import base key embedding model. This is my code that you have to ignore. So basically, I don't want to expose my keys. That is why I have imported it from a constant file. Okay. So in order to use the code, in order to save the files as embeddings, so सबसे पहले मैंने एक path set कर ली है dbFaiss path, which is vector store slash dbFaiss. So यहाँ पर एक folder created है vector store का, and after that I'm loading the file. So loader is equals to py loader. मैं load कर रहा हूँ उस file को, and from this loader I'm getting all the documents. So docs is equals to loader dot load. It basically returns all the documents, and then I'm passing all these documents in the text splitter. So यहाँ पर हम we are splitting the text into chunks, and the chunk size I have specified is 1000. This is just for the tutorial purpose. You can set whatever you want based on your requirement, whatever suits best. You can set it. Um, so the splits that I got here, then I have split it into the sorry, the text splitter we set here, and in the text splitter we split the document that we already have. So basically the documents that we have loaded, we pass it in as an argument, and we got all the splits. Okay, तो यहाँ तक हमने document को load करके we have chunked it out, and now I'm going to store it in the DB. So यहाँ पर fairs dot from documents, this is the syntax. यहाँ पर मैं अपने splits pass कर रहा हूँ. Along with that, I am passing the embedding that I want to use. So I am basically using the text embedding large model of OpenAI, and I have passed the endpoint, the key, the API type, and API version. The dimensions I am using is 1024, and after that, at end, I am saving the path, saving the embeddings into the local path. So once I run this file, you will see in the vector store, we will have some pickle file which will have the embeddings. So we are just going to run this. So Python load data.py. Okay. Yeah, so as you can see in the vector store dbFaiss, index.faiss and index.pickle is created. So these files are used as the knowledge base store that we are going to use in the retrieval process. So this is about the loading the data and storing it as embedding. So we have created our knowledge base. Now the part of retrieval comes. So let's move on to that. सो अभी हमने क्या किया है, वी हैव क्रिएटेड आवर वेक्टर स्टोर. तो हमारे वेक्टर स्टोर में डेटा यहाँ पर आ गया है. इफ वी सी इट फ्रॉम द पर्सपेक्टिव ऑफ द आर्किटेक्चर, तो द नेक्स्ट पार्ट दैट वी कैन सी फॉर दिस आर्किटेक्चर, अभी हमें एक यहाँ पर LLM चाहिए. तो बेसिकली वी नीड एन इंस्टेंस ऑफ एन LLM. वी नीड अ कंटेक्स्ट क्वेरी प्रॉम्प्ट जो कि यूज करेगा यूजर की क्वेरी को टू गेट द डेटा फ्रॉम LLM. Also, we need a retrieval process. Like abhi we have just created the database. We are not loading it anywhere. We are not retrieving it from the database. So these three things we have to do, okay, before performing the main operation. So for that, if we move to the code part, सबसे पहले I have written a function जो कि which will load the knowledge base. Okay, so what it does is basically जो हमने यहाँ पर database create किया है, it will load it into the uh, a variable. It will load it as an embeddings, and so this function will return the knowledge base. So इसके लिए the code that I have written, I have again created the embedding same as the previous that we have done. The same model I have used, the path I have given, and I have used this function faiss.loadLocal. So basically we are loading from the local pickle file and loading it in a variable db. So, and we are returning this as the vectors that we have. So this function will return an instance of the DB, the Faiss DB that we created. Okay. Second one is the load LLM. So this function creates an instance of an LLM. So here I am using Azure Chat OpenAI. I am using the text model which is 35 Turbo, GPT-35 Turbo, and the 16K model I am using. So I am passing a parameter temperature 0.5. You can pass other hyperparameter as well for the LLM. So this function will return an instance of an LLM. And then there is a load prompt function which will set up the prompt from this architecture. So we have set up the LLM, we have set up a function which will retrieve the result, and we have now we are setting the prompt. Okay. So for the prompt, I have written a prompt basically that you need to answer the question in the sentence as same as in the PDF content. So given below is the context. So we will set up the context. The context here specifies the PDF content. Okay, so moving on, when we will call these functions, you will get to know. And question is basically the query that the user will pass. Also, I have given a case that if answer is not in the PDF, then return sorry, I don't know. Okay, and then after setting it up, this is returning the prompt. So this is the code to set up the architecture completely. Okay. Now we will move on to the query part. Basically, how do we inference with this architecture and how do we get the actual results from it? Okay. So for the last part of the inference of the RAG architecture, um, just bear with me. It's a bit complex to understand this code. So starting up, ये functions मैंने already बता दिए हैं कि we have written this function. So in this main part, सबसे पहले I am calling this load knowledge base, then load LLM, load prompt. तो तीन ये functions को मैंने call किया है. After that, I am taking a query as an input. Okay, so जो input मैं user से ले रहा हूँ, return की enter your query below और उसको storing it in the query variable. Then as you can see on the line number 53, I have written similar m is equals to knowledge base dot similarity search query. So ये क्या करता है बेसिकली जो knowledge base हमने already load किया है इसमें से it will perform a similarity search based on the text that we have provided. Okay, so as you can see it says return docs most similar to query. तो इस पर्टिकुलर क्वेरी को जो भी हमने इनपुट दिया है इससे जितने भी मोस्ट सिमिलर डॉक्यूमेंट्स होंगे तो बाय डिफॉल्ट इट इज 4. यू कैन ऑल्सो प्रोवाइड एन वेरिएबल ऑफ के. so by default it is 4. तो अभी के लिए it will return the 4 most similar documents. Okay, फिर what I'm doing is कि I'm using these 4 similar documents, passing it through the Faiss. Then in 4 similar documents I'm creating a vector store. Okay, so this Faiss.from documents, it will create a vector store for this 4 documents. Again, I'm passing the same embeddings as the previous one. So same embedding type की एक ये हमारे को एक vector store यहाँ पे return कर देगा. Okay, then on the line number 65, what I am doing is कि इस vector store को I am using a function called as retriever. Okay, so this as retriever, it will return a vector store retriever. So basically जो हमने यहाँ पर vector store create किया है, इसमें हम एक function use करेंगे as retriever और हम एक vector store retriever यहाँ पर जो है उसमें उसको हम एक variable में store कर लेंगे retriever में. Okay, yeah. So on line number 66, I'm basically setting up a runnable interface. It is a LangChain runnable interface. You can check it out for more details on this link. So you can check it out about the runnable interface. यहाँ पर all the details are provided, how to use the runnable pass-through and the runnable interface. So here I'm setting up a runnable interface. Basically, I'm setting up a chain. Okay, and जो context में I'm providing the retriever. So जो retriever हमने अभी अपने vector store से create किया है, उस vector store retriever को I'm passing it as a context. And then the question is a runnable pass-through. You can again check it out on the LangChain documents. The prompt that we have previously created here, the prompt, the LLM, and the string output parser. It is an output parser provided by the LangChain. So it passed the LLM result into top likely string. Okay. So after setting up this runnable interface, I am basically invoking the query. So response is equals to ragchain dot invoke the query, and I'm printing the response here. Okay. So let's run it. Python main.py. Before running it, let us see the data. As you might remember, it was the cancellation rules for IRCTC. So, abhi, what I'm going to do is I'm going to ask questions related to that. Okay. So, let's say I ask the LLM key, what amount will be deducted if I cancel my ticket. If So see, based on the context, इसने उस PDF में से the data निकाला कि 240 plus GST will be deducted if you cancel your ticket. Okay, now this question can be asked in multiple ways, and LLM will understand it, and because the context is already set, it will return the output from the PDF. Okay, let me ask some other question as well. Um, what will happen if I cancel, or let's say if my ticket is cancelled, or if my train is cancelled. Let's say if the LLM is able to answer this or not. Okay, so it has returned us the output कि if the train is cancelled, the full fare will be refunded back to all passengers. So let's see कि क्या PDF में ऐसा provided था और LLM ने खुद से ऐसा output दिया. Okay, so let's say cancellation charges for full cancellation of ticket. And हमने भी कुछ ऐसा ही इससे पूछा था. If the train is cancelled, the full fare will be refunded back. Automatic full refund, right? So let's say इसने output कहाँ से निकाला है? If train is cancelled. Okay, so basically जो LLM है इसने यहाँ से context set किया है, and based on the context it has provided as an output कि in case of full cancellation of train, full refund of fare will be directly credited back, and online cancellation or filing of TDR is not required. और यहाँ पर इसने क्या बोला, full fare will be back provided the train is running late by more than 3 hours. TDR is filed online before the actual departure of train. However, if the ticket is cancelled, the request of full fare is filed online. After the actual return, no refund or fare will be admissible. Okay. So basically, it understood the context. On based on that, from the context, it is returning the output. So again, let's say if I ask a question, where can I find the TDR filing rules? Let's try that. So where can I find the TDR filing rules? So it has given us an link. Yes, the link is same as from the PDF. So this is basically it for the RAG implementation. It was a rough tutorial that I have given. तो मैंने अभी इसमें कुछ भी डेटा मॉडिफिकेशन डेटा को प्री प्रोसेसिंग नहीं किया. I have just taken the PDF and stored it in the Faiss, and based on the architecture that I have shown previously. Yeah, so based on this architecture, as you can see, हमने क्या किया, सबसे पहले एक हमने डॉक्यूमेंट्स को लिया, एम्बेडिंग मॉडल का यूज किया, we store it in the vector store, Then we created instance of LLM, we created some prompt, we created a retrieval from the vector store, and using the query जो हमने context query prompt set किया था उसके basis पे we have taken the output. Okay, so this is about the RAG part. There are many applications like Q&A bot. You can set interview questions, answers, all those use cases where RAG is used. So you can check it out, try some more, and comment below if you want to ask something. I will be adding the GitHub code for this, GitHub link for this code, maybe in future. Um, and stay tuned, like, share, subscribe if you like the video. Bye bye. Thank you.